Hey, have you ever just looked up at the night sky and really thought about how utterly bonkers it is that we know anything at all about what's out there? I mean, it's not like you can just, pop on over to a nebula for a quick peek, right? It truly fries my circuits sometimes.
It's a completely valid feeling.
Yeah.
That sense of awe, coupled with the almost uh, comical inaccessibility of the cosmos,
Mm.
is something that drives a lot of scientific inquiry. And you're spot on. The limitations of our physical presence out there necessitate some pretty clever ways of understanding what's what.
Clever is definitely the word for it because when you think about it, you're walking around with these incredible sensory instruments, your eyes, your ears, all that jag, perfectly tuned for life here on Earth. But try using those to figure out what's happening around a black hole. Good luck with that, right? It's like trying to listen to a symphony with a pair of oven mitts on.
Huh. That's a wonderfully apt comparison. Really is. Our senses evolved to detect a very specific range of stimuli relevant to our survival, in this particular environment. The universe, however, operates on a vastly different playing field, with energies and phenomena far beyond our everyday experience.
Okay, so if our regular peepers are basically useless for most of the cosmic heavy lifting, how do we actually manage to see all those mind-blowing galaxies and exploding stars that you see in the pictures? That's where our nerdy gadgets come in, right? We've built these super-powered extensions of our senses.
Precisely. The development of the telescope, for example, was a total game changer for your understanding of the universe. I mean, just completely. Suddenly, things that were completely invisible to the naked eye, the craters on the moon, Jupiter's moons, they just popped into existence. It was a fundamental shift in how you perceived your place in the cosmos.
And it didn't stop with just making things bigger, did it? Now we've got this incredible toolkit. We're not just looking at the pretty visible light anymore. We're catching all sorts of cosmic whispers that our eyes can't even register.
Exactly. We're talking about the entire electromagnetic spectrum, which, includes everything from those radio waves that bring you your favorite music to the super energetic gamma rays. Each part of the spectrum acts like a different kind of cosmic translator, revealing a unique aspect of the universe.
Okay, let's dig into that a bit. So, if you were to tune one of these cosmic radios to pick up radio waves, what kind of secrets would you uncover that are invisible to your regular vision?
Well, what's truly fascinating is that the familiar daytime sky, which appears so bright to your eyes, it essentially disappears when you look at it through a radio telescope. Yep. Gone. Instead, certain incredibly bright sources emerge. One of the most prominent is the very center of our own Milky Way galaxy, a region that's completely obscured by dust and gas when you try to view it with visible light, like through the constellation Sagittarius. Radio waves, however, can penetrate that cosmic fog, giving you a clear view.
Whoa, so it's like having a secret back door into the heart of our galaxy. That's wild. What about microwaves? I remember reading that the early universe has this microwave glow. That sounds almost unbelievable.
It is quite something to contemplate. It really is. If your eyes were sensitive to microwaves, the entire universe would appear to have a faint, uniform glow. This is the cosmic microwave background radiation, and it's essentially the afterglow of the Big Bang, the incredibly hot, dense state from which our universe originated about 13.8 billion years ago. Think of it like being able to see the residual heat from the universe's initial fiery birth.
A literal echo of creation. Wow. That's a powerful image. And then there are X-rays you mentioned, those can help us find black holes. How does that work since black holes are supposed to be?
Well, invisible, right? That's correct. Black holes themselves don't emit any light. Nothing gets out. However, their immense gravity has a dramatic effect on the matter around them. When gas and dust get pulled towards a black hole, it forms this swirling disk called an accretion disk. As this material spirals inward at incredible speeds, the friction generates immense heat, millions of degrees, causing it to emit copious amounts of X-rays. So while you can't directly see the black hole, you can detect the energetic light show of matter as it takes its final plunge. It's like finding the drain by seeing the water circling around it.
Huh. That's a pretty intense way to spot something that's supposed to be invisible, like following the smoke to find the fire, only, on a cosmic scale. And finally, gamma rays. They sound like the superheroes of the electromagnetic spectrum, super energetic. What do they reveal to us?
Gamma rays are indeed the highest energy form of electromagnetic radiation. Yeah. When you observe the universe in gamma rays, you see these incredibly powerful, short-lived bursts of energy appearing across the sky, happening roughly once a day. These are often associated with the most extreme events in the cosmos, such as the collapse of very massive stars or the violent merging of neutron stars. Really extreme stuff. These explosions are so energetic that they heat up the surrounding gas to incredible temperatures, causing it to shine in other parts of the spectrum as well. It's often a multi-wavelength story, with gamma rays announcing the most dramatic events.
So basically, by collecting and interpreting all this different kinds of light, you can build up this amazing picture of the universe, even though you can't physically visit most of these places. It all boils down to understanding the messages these cosmic objects are sending us.
Precisely. Yeah, exactly. Even though you can't touch a star millions of light years away or travel to the edge of the observable universe, the light and other radiation that reaches us carries a wealth of information about their composition, temperature, motion, and even their history. And what's truly remarkable, I think, is that the fundamental laws of physics that govern how things work here on Earth are the very same laws that dictate the behavior of these distant objects. That universality is the key that allows you to decode those cosmic signals.
It's almost mind-boggling to think that the same forces that make your toast pop out of the toaster are also responsible for supernovas light years away.
It truly is a humbling realization. It really is. And sometimes what you initially see isn't the whole story. Take the historical example of nebulium. When early astronomers looked at the light from these glowing clouds in space called nebulae, using spectroscopes instruments that break light into its component colors, they observed spectral lines that didn't match any known element here on Earth. So they hypothesized the existence of a new element and named it nebulium.
Nebulium. Okay, that sounds like something straight out of a Jules Verne novel. So, what was the big reveal? What did nebulium turn out to be?
Well, what's fascinating for you to consider is that it wasn't a new element at all. Turns out it was ordinary oxygen, the very same oxygen you're breathing right now, but behaving in a way that was completely unexpected. See, in the extremely low density conditions found in these nebulae, atoms can exist for extended periods without colliding with each other. Under these unusual circumstances, electrons within the oxygen atoms can make specific transitions and emit light at wavelengths that had never been observed in the denser environments of laboratories on Earth. So, nebulium was simply the signature of a familiar element acting in an unfamiliar cosmic environment.
That's such a cool example of how your initial observations might not always give you the full picture. It's a good reminder that the universe can be a bit of a trickster, right? Showing you something that looks new when it's really just something old in disguise.
Exactly. The universe is full of phenomena that have no direct parallels in your everyday life. Million-degree plasmas, the crushing gravity of black holes, the immense energy of gamma ray bursts. You don't encounter these things on your morning commute, thankfully. Yet the fundamental principles of physics that you learn about are the very same ones that govern these seemingly exotic cosmic events.
So, if so much of what you know about the universe comes from carefully analyzing these faint signals that have traveled across vast distances, it really makes you wonder, doesn't it? What other secrets are still out there waiting to be discovered? Maybe in parts of the electromagnetic spectrum that we haven't fully explored yet, or in the subtle nuances of the signals that we're still learning how to interpret.
This raises a really profound question for you to ponder. Yeah. What aha moments are still waiting to be revealed when you develop new ways to see the cosmos? What are we currently missing by only looking through the familiar windows of the electromagnetic spectrum, or by not yet fully understanding the language that the universe is speaking to us in?
It's a truly mind-bending thought. It feels like we've only just scratched the surface of understanding this incredible universe we live in, and the potential for future discoveries, for new ways of seeing, is just absolutely limitless for you.